In this video, you will learn how to use the table, but also the calculator and online calculators to calculate area underneath the curve for a standard normal distribution. So, with our 68, 95, 99.7 rule, which is our empirical rule, we were able to answer questions like, hey, what's the probability that someone has a z-score between 1 and 2, or between -1 and +1? Now we will be able to answer questions for any numbers in between. So we'll look at 3 different scenarios. We'll look at it first on the table, then on the calculator, and then using an online calculator. So the question is, what's the probability that a z-score is less than -1.42? Well, when we go over to our z-score table, we're going to see that there's a positive and a negative side. And we're going to use the negative side, find the area below -1.42. Okay, so here's our z-score table. We're going to go down to -1.4 over here. And then we need the hundredths digit is up on the top. So we have the ones digit and the 10th digit in over on the left, and we have our hundredths digit on top, and then we're going to simply see where those two connect, and we have a probability of 0.0778. And just to show you kind of the image above, the one thing about the z-score tables is it always gives us area to the left, which means if I'm trying to find the area to the right, I'm going to have to first find the area to the left and then use the fact that my total probability is equal to 1, and then I can subtract my probability from 1. So in our example, -1.42, that means I'm trying to find the area to the left, which is what the table gives me. Again, I go down to -1.4 on the left, 0.02 on the top. I look where those two connect, and that's a probability of 0.0778. So the probability that the z-score is less than -1.42 is 0.0778. Now we're going to look at the next scenario. This is looking at the probability of z being greater than 1.95. So again, we already said when we're looking for the area to the right, which is the greater, we are first going to find the area to the left on our table, and then we're going to use the fact that our total area is equal to 1. So this is 1 minus the probability that z is less than 1.95. So on our z-score table, we're going to go to the positive side. We're going to find 1.9 over on the left, 0.05 on the top, and see where those two connect. So 1.9, 0.05, putting those two together, we end up with a value of 0.9744. So the area to the left is 0.9744, which I'll indicate over here with the arrow, but I want to look for the area to the right. So the probability that z is greater than 1.95 is equal to 1 minus the probability that z is less than 1.95, which is the area we just found. So it's 0.9744, and subtracting it from 1, we end up with 0.0256. One other thing we could have done is, because of the symmetry of our curve, the area to the right of 1.95 is actually the same as the area to the left of negative 1.95. So this is the case in our standard normal distribution. So instead of looking at 1.95, finding the area to the left, subtracting it from 1, we could have gone to the negative side, to negative 1.95. And I already have this highlighted right here, which is an area of 0.0256, just like we got it. Our next scenario, so third case, is where we're looking for the probability between two values. So over here, we are looking for the probability between negative 1.02 and positive 2.57. So again, looking at our table, we can't find the area between two values. What we can do is find the area to the left of negative 1.02, then find the area to the left of 2.57, and then we can subtract those two areas. So let's start by looking at the area to the left of negative 1.02. So again, being on the negative side, negative 1.02 gives us an area of 0.1539. So that's equal 1539. Now we're going to find the area to the left of 2.57. So this time we're going to the positive side. To 2.57. So 2.57 up here and going over to, that looks like it's 0.9949. So 0.9949. And as we mentioned before, we're going to take the larger area, which was the 0.9949. We're going to subtract from it the smaller area, which is the 0.1539, in order to get the difference of those two. So the probability that our z-score is between negative 1.02 and 2.57 is equal to 0.9949 minus 0.1539, which is a difference of 0.841. So on our calculator, we are going to go to our normal distribution. And what we have to do over here, very similarly to what we looked at before, is we're going to put in an upper and a lower value. And since we are looking for the area to the left, and we don't really know where that area starts, we're actually going to put in negative infinity for our start value. Then we're going to put negative 1.42 by our ending value, and we're going to use something called the normal CDF. So on our TI-84, we go to second vars, which takes us to the distributions. Then we are going to go to normal CDF. We're going to hit enter. We're going to put negative infinity as our lower value. We could also do like negative 100,000 or a very negative value. But I'll show you guys how to enter in negative infinity on the calculators. So you have to use the negative symbol. If you put a minus in there, it's going to give you an error. And then we're going to use the second button and the comma, which is the EE. And then we're going to use 99. So this is actually negative 10 to the 99th power. So it's a 1 with 99 zeros. So it's a really, really small number. Our upper value, again, we're going to enter negative 1.42. We're going to hit enter, enter. And over here, that automatically puts in our mean of 0, our standard deviation of 1. And it gives us an area of 0.0778, same way we found it on the table. For our second scenario, we are finding the area to the right of 1.95. We already have the image over here on the right. So this time we're going to use 1.95 as the lower value, and then we're going to enter in infinity or E99 as the upper value. So again, going to second vars, normal CDF, we're going to put in 1.95 as our starting value, and then positive E99, again using the second and the comma button, as our upper value, and this is going to give us a probability of 0.0256. And then the last scenario, which is actually the easiest one over here on the calculator, this is where I already have a lower and an upper value given, because over here, this would be my lower bound, this would be my upper bound, and we're already looking for the area in between two values. So this makes it even simpler to use our calculator. So second vars, we're going to use the normal CDF, put in negative 1.02 as our lower value, 2.57 as our upper value. We're going to hit enter over here, and this is going to give us an area of 0.841. So just like we got it when we manually calculated it. One thing that can happen sometimes with the rounding, we could have a slightly different answer when we're using the calculator, but it should be very, very, very close.